In this video, we are going to revisit our focus questions, which are in the study section of the notebook, and they're here. We've already written these out. I'm going to answer questions 1 and 3 first, and then we're going to really do some intensive work on number 2. So let's tackle number 1 first. What is the unit of measurement for temperature? Now, can you recall those units of measure? And remember, I want to put this in sentence form. So I think I wrote these questions in blue. That looks blue instead of black, but that's okay. The unit of measurement and remember, we have more than one unit, so we want to put an S on there. The units of measurement for temperature now the question uses the word is, but I'm talking about more than one, so I'm going to say are. The units of measure for temperature are Fahrenheit, degrees, and actually, don't erase. Let's just mark out that where I started to write degrees. I'm going to come up here and I won't have to keep writing the word degrees. Are degrees Fahrenheit in the customary system. Then put a comma. Celsius or centigrade in the metric system. And do you remember about the SI system? What is it called? Capital K, it's Kelvin in the SI system. And you can use that. That is an acceptable abbreviation. You can also write it out if you want to. International system, you could definitely write that out. So let's read this again. It says the units of measurement for temperature are degrees Fahrenheit in the customary system, Celsius or centigrade in the metric, and I should have put the word system there, and degrees Kelvin in the SI system. So it depends entirely on the system you're using. This particular book talks about the SI, so I think the answer they're looking for is Kelvin, but we need to be sure that we completely answer the question. And then let's jump down here to number 3 where it says, what is time? Now this is one of my flashcards. I can simply use that definition. Let's put it in sentence form. Time is the interval, and remember what word I told you you can think of when you see interval? Another way to say that is space that passes between two occurring events and there's more. We can put a period here and say it can be measured on a clock or stopwatch. And if you want a picture representation of that, draw yourself a line segment. A line segment has a dot on each end. And remember, we talked about a runner in a race where you start and you finish. This space is called the interval. And time would be how much time it takes to start to finish. You measure the interval. Okay, to get number 2, I want to do a graphing exercise with you. So we're going to need some data to graph. So I want you to draw in a table. Just come over here after the question and let's draw a box. And we're going to put 2 columns in this. Actually, let's make 3 columns in this box. If necessary, just add a column over here. And then I'm going to put a column. I don't like that. That will drive me crazy. I need to line it up there. It's not much better, but it'll work. So let's put 3 columns in this table. This is a matrix, if you want to think of it that way. And let's make a header row. So we're going to put substance in this first cell. And we are going to compare 3 substances. We're going to compare water. And I didn't need that. Let me just straighten mine up. You don't have to do this. It just drives me crazy. I'm sorry. I'm a little bit OCD that way. Okay, so here is the table. We're going to compare water to mercury, which is an element. And then we're going to compare a chemical called benzene. Okay. And then I'm going to give you some numbers for mass and volume. And you know what? I need another. Now let's do it this way. I'm sorry, guys. I should have planned this out a little better. We're going to put mass over volume. And then in this column, I want to put density. We're going to have to do a little bit of calculation here. And I'll do that. If you have a calculator, go ahead and get your calculator ready because we're going to need it. Okay, so let's add some numbers here. I'm going to tell you that 35 grams of water, that's the mass, will match up to 35 milliliters volume. Okay, so if you take 35 milliliters of water and put it in a test tube, it will weigh 35 grams. That's its mass. Let me not use the word weigh, because remember on the moon, it's going to weigh something less. On Earth, 35 milliliters of water weighs 35 grams. It has a mass of 35 grams. Okay, 34 grams of mercury has a volume of 22.5 milliliters. And don't worry about where I'm getting, these are just numbers that I know to be true. So you don't have to worry about where they came from. I just want you to follow what I'm doing with the math. So the mass, the amount is 34 grams of mercury. The volume is 22.5 milliliters. And then finally, this chemical called benzene which can cause cancer. You don't want to be around benzene. We have, I'm sorry guys, I messed up on mercury. I'm just not doing very well with this. On mercury, this is what we had, 22.5. Just cross out one of those 2's. You just want 2.5. Okay, on benzene, it's 22.5. I looked at the wrong number, which is not at all uncommon for me. So here are the numbers that we need. If you need to pause your video and complete your table, please do. I'll be here when you're ready. Okay, so to do the math, to calculate the density, let me remind you, just hang with me here. On the flashcard for density, what does it tell us to do? Density is mass divided by volume. So I'm going to go back to that page we're working on, and we're going to do that using a calculator. Now for water, I don't need a calculator because 35 divided by itself is a density of 1. And I'm just going to put a 1. Let me go ahead and give you the units. They're not that hard to understand. You're going to take the G for the mass. That's that SI unit. And then milliliter for the volume. So grams per milliliter. 1 gram for every milliliter. All right, so let's do using our calculator, and I'll tell you exactly how to type it in. Let me get to mine. We're going to do clear, all clear, then 34 divided by 2.5 is 13.6 grams per milliliter. And then to do benzo, let's do clear. 20 divided by 22.5 is 0.88, repeating, grams per milliliter. And I'm just getting the grams per milliliter from these numbers, G over ml, G over ml. We don't have to worry about that. I just want to be sure that you're getting these numbers. Okay, so remember I told you that science and math are brother and sister? This is one example of that. So what I've done here, I've given you 3 substances. I have given you their mass and volume, and you have helped me calculate their densities. So now we're going to graph this picture. So I want you to use a straight edge, if you would please, and draw yourself a graph frame. And you can use all this space that you need. I really should have used graph paper to illustrate this, but we'll make it. We'll be okay. So we have the y-axis, which is the tall axis, and we are going to graph mass on the y-axis. So go ahead over here. Let me do it first. You watch me, and then you can do it. So mass, and that's measured in grams. And I'm going to turn that around. So you go ahead and do this too. You can turn your book around. Mass in grams, and then the x-axis is going to have the volume in milliliters. So down here we're going to label the x-axis volume in milliliters. Now if we had an independent variable, we would put it down here, but we don't. We're graphing density. So mass and volume. Now we need to put a scale on our graph, and I'm going to start with, this is 0 right here. So I'm going to leave a line, and then I'm going to make this be 10.0, an even 10. Another line, and then another line, and we'll put 20.0. Then two more, and we put 30.0. So this axis is scaled by 5. Each line that I climb is worth 5. So there's 45, here's 50, here's 55, 60, 65, 70, and that's as high as we need to go. We didn't really even need to go that high. Okay, and then across the bottom, I'm going to put some space. We need to stretch these out a little bit, so we're going to have 10 milliliters, 20 milliliters, 30 milliliters, and then I think 40. We can go up to 40, and we'll have that one. Okay, so I've just drawn a basic graph. We're going to make a line graph here. The y-axis is scaled by 5s. The x-axis, that's this one, is scaled by 10s. Okay, so let's take our water figure right here. Water is 35 grams, 35 milliliters. All right, so water, if I go out to 35 milliliters, that's going to be about right here. This would be 35. And so that line needs to go up to 35 on the y-axis. It's 35 and 35. So we're going to look at, here's the 35 line up here. And here's the 35 line right here. So we're going to plot a point where those two lines meet. Okay, 35 and 35. Where they meet, where they come together, I want you to plot a point. Okay, so that would represent the density of water. And I'm going to go ahead and erase these blue marks because you really don't want to draw those. You do that in your head. You just draw the dot. And I'm going to name this dot W. Okay, water. All right, let's look at mercury. Mercury was 34 grams. That's the mass. So that's going to be right up here, not quite to that 35 line. So right in there. And then we have 2.5 milliliters of water. So that's going to be way back here, somewhere right there, the 2.5. And you can put that in there if you want to. But remember, we're not looking for the blue lines. We're looking where the blue lines meet, where they come together. So the red dot for mercury is going to go right there. And I'm going to erase my blue lines because you really don't want to draw those on your actual graph. But just until we learn how to graph, I'm going to use that as a visual aid. And this is point M for mercury. So at the same, water's at 35. Remember, water was 35, 35. Mercury is 2.5 and 34. So they're about the same height, but look at how much more, how many more milliliters of water are necessary. Mercury is, you have much less milliliters, but you almost have the same mass. So that tells me that mercury is much more dense than water. Water, you have the same height on this graph, but it takes 35 milliliters of water to get us to that height. So let's try benzene. Benzene is a chemical. You can breathe it in. You don't want to breathe it in, but you can. So it's almost, you could say, in a gas state. Yeah, I would expect the density of benzene to be much lower. So let's plot benzene. It's going to be at 20 grams and 22.5 milliliters. So here is the 20 grams. And then 22.5 would be somewhere very close to 20, right about there, I'm going to say. You can go ahead and put that number in, just so you can remember. And where those lines intersect, we're going to put the density of benzene. So, let's see what this tells us. And I'm going to go ahead and call this point B. Benzene is not as dense as mercury and water at these amounts. So, B for benzene. Okay. Now, I'm going to draw a line. Let me think. Yes, I'm going to draw a line through each of these points, and I'm going to change the color of that line. So a straight line, just bear with me here. I'm always going to start here at origin, and I'm going to take that line through point B, and I thought that's what was going to happen. I didn't quite nail it down. I'm still not nailing it, and I maybe can't because there we go. That's close enough. Okay. I'm going to do the same thing for water. I'm just letting a line of best fit go through there. That one was spot on. And then I'm going to let that happen also with the mercury line. Let me try it this way. Nope. I'm trying to get it to pass right through that point. And that one is way off. Okay, we're just going to leave it there. Pretend that it's right through that point. So what this graph is showing me, we could give it a title. We have graphed the densities of these substances. And I want to show you where I got this idea. Mercury, benzene, and water. I want you to look at the graph that we've drawn, and then I'm going to show you one if I can get back to it on the internet. This is where my idea came from. And you see that our graph and their graphs look just the same. Okay, this is from a website called chem.libretext.org. I believe this is a college level course that explains about density. Okay, so that's where this very complicated, or actually our graph, which is pretty simple, it's not easy, but it's pretty simplified, comes from this very complicated text. And if you would like to read more about it, you can go to the website. Again, it's called chem.libretext.org. I'll write that down for you. chem.libretext.org. So that's the website if you want to read more about this particular graph. It's very complicated to read. So if you don't enjoy this type of reading, I would not recommend it. But it's a good thing to read if you want some challenging reading. So density is the amount, how tightly things are packed. You can calculate density if you know mass and volume. You can graph density if you know the numbers. Once you get these numbers, you can build a graph. So we could add to this chart, we won't, but we could add milk, we could add liquid gold, we could add any substance that we wanted to if we know the mass and the volume, we can find the density. I also wanted to show you another version of a line graph just for practice on that. Okay, I'm not sure what the next video is, but it'll be good. So I'll see you soon. If you have questions about this particular lesson, please talk to your instructor. I will see you soon. Bye-bye.